Hey guys, how's it going? So today actually we're going to be looking at remove duplicates from a sorted array. So this is one of those questions which have more uh, dislike than like, but I still pretty much believe that it's not a bad question after all. Given that there's over like 9,000 of people that did like this question. So given an integer array num sorted in non-decreasing order, remove the duplicates in place such that each unique element appear only once. So the point is that we're given a sorted array and the numbers are sorted in an increasing order. So we just need to remove duplicates. And this is one of the keywords that you should actually note is that we should do this in place, meaning that the space complexity should be of 1. So we don't have to create a memory. Okay. Yeah, so we're gonna look at this question and see actually how we can go about it. So just to give you guys an example, let's say we have 1, 1 and 2. So what is required from us is that we need to return 2. So because we essentially going to remove this one or this one, but we have to remove 1 because these are duplicates. Okay, so we're gonna be left with 1 and 2. So the length of this is gonna be 2. That's what we need to return. So that's all is in it in this question. So how would we then go about this? So one way we were gonna go about it, it was the one that actually was gonna take our space. The space was gonna be O of n, because what we will do is that we will loop through the array and we will count the number of times each value occurs. For example, we'll start at this element, we'll store it into our hash map and say we saw this one once, then we'll go, we say okay, we saw this once 2, and we will know that okay, if it's greater than 1, then that means here these are duplicates. So it's more like we're keeping track of all of the numbers that we're looping through. But now the problem with this is that they don't want us to use any memory, so we have to do this in space, in like, right? So not in space, in O of 1 space. So what am I thinking then? I am thinking that given this array 1, 1, 2, how about we still loop through, but as we get to each element, we look backwards. So we look at the previous element. So we say what's there. Here it's 1. So we know that there's duplicate. So we're gonna have to remove this element. Then we continue, because they could be multiple ones. They could be 2. So we have to move here. Actually, let me make it a little bit more complex so that we can see actually how. So we know that here we need to return 2 because there's only 2 unique values, right? So what we're going to do is that we're going to start here. There's nothing backwards to look for, so we continue. There's something to look for, we remove this. Okay, we continue. There's what's backwards. Backwards is that one, so we remove this. We continue. What's backwards? Backwards is 1, so they're not duplicates, so we're not removing this. We continue. What's this? Backwards is 2, so we remove this. What's backwards? Backwards is 2, so we remove this. So we left with these 2 elements. We left these 2, and we've left with this 1. So that's essentially the idea, right? So yeah, let's get into the code. I feel like this one is straightforward. It's an easy question on LeetCode. So yeah, I think it shouldn't take us too much time. But don't worry, I'll explain everything that I do. So what we're gonna do is that I'm gonna take in n equals to, so this is not a space. I'm not creating some sort of like an array, and besides this will be constant because we're taking the length of nums. So this is not a space anyway, so it's just O of 1. Then I'm gonna say for I in range of n, and what we can do is that we're gonna say while I is greater than 0, So here, remember that we need to look backwards. But what happened um, if the elements they start, like we're starting from, we have to, the first index does not have backwards. So for example, what I'm saying is this. Let's say we have 1, 2, 3, 4, right? So when we start from index 0, which is 1, it does not have backwards. So what we're doing is that we want to start to look backwards where the index I is greater than 0. Okay, so which means that we're gonna start to look backwards at index 1, which is 2. We're gonna start to look at backward because there's an element. Okay, that's what we're doing. Then why am I using a while loop? I'm using a while loop because you can think if like we have 2, 2, 2, 2. So we want to say, because these are sorted, we know that they're sorted, so we're leveraging that. So we're going to say, when we get here, this element, this is 2 is going to look back and it's going to find that it's 2. Then we're going to do this. We're going to move until we got to a unique value, right? So we're going to have to say, while I is equal to, is while I is greater than 0, and we're gonna take nums I minus 1 is equals to nums I. So which means that we're looking at the previous element and the current element. Are they the same? Yes, they're the same. Then we want to increase we want to decrease the length of the array because we're removing them, or we're gonna delete them rather, right? And we want to make sure that as much as we continue with this, we want to keep the index to be less than n. So that's another thing that we want to check. So what I'm going to do here is that, because we know guys that we have duplicates, because the previous element is equals to the current element, then let's delete it, right? So we're going to say nums I, then we take the length of the array, we decrease it. We're going to say minus equals to 1. Why are we decreasing it? It's because you can imagine that the length was initially, let's count this. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So let's say this was initially 8, right? Let's say this was initially 8. And we keep on deleting these numbers as we go along. But if we don't decrease this 8 also, we don't decrease it, then you will see that we will go out of bound, and that's not right. So what we need to do is that we need to decrease also the length of this array as we go on, as we delete. So let's say we delete 2, we decrease, so that the range here does not go out of bound. Hope that makes sense, guys. Okay, so yeah, we done, and we're gonna return length of n and length of nums, because we're deleting in space. I forgot that they said we should do it in space. So yeah, we're deleting this in space. So in that array that we're given, so this should do the trick, and it does. So I'm gonna submit, and it worked. So thanks guys, this will do it. And yeah, we solved this question in O of n, and the space was O of 1 because we did not use any memory. So thank you very much, and bye.